So this is a very important topic. So internal field, because so one of the most important question in this topic is, so this is the internal field here. So I think previous unit that lasers and fiber optics. So in that important questions, so I will tell the important questions on the on that topic. So those are, so first one is the helium neon laser. So one is the important question, and ruby laser. So these two. So important questions in laser is helium neon laser and ruby laser. So remaining all are fundamentals. So what about the laser? It will be there. Those are the fundamentals. So just read those fundamentals, definitions of spontaneous emission, stimulated emission, and what is that? N1 N2 greater than N1. So population inversion, pumping mechanisms. Those all are the just fundamentals of the lasers. Just read once, and main important questions on that laser is ruby laser and helium neon laser and semiconductor laser. So these three are the main important questions on that. So lasers, and in that fiber optics. In that fiber optics, what is the important question in first one? So types of optic materials will be there. No? Types of fiber optics: step index fiber, grade index fiber, and single mode, and so multi mode. Along with the types of optical fiber, they will ask attenuation. Attenuation, just to, so two types of attenuation are there. Na? So those two types of attenuation, read that. And one more is the numerical aperture. So if they ask numerical aperture, means you have to write so from starting onwards, where means so that principle will be there now. So total internal reflection, principle of optical fiber. So from there you have to start, so and up to numerical aperture you have to write. Okay, so main important question in fiber optics is, so find out the numerical aperture. So numerical aperture means you have to find out the first acceptance angle. So there is a relation between acceptance angle and numerical aperture. So that you have to write. Okay. So that is the numerical aperture. And second one is the types of optical fibers. Types of optical fibers means so step index and graded index optical fiber, as well as so along with that step in, so the types of optical fiber, they will ask attenuation also. Attenuation, that means losses in optical fiber. So those are the important questions, 4 important questions. So 4 or 5 important questions in that. So third unit, sorry, fourth unit. Okay, now coming to the, so in this unit, so one of the important question is here. So this one, internal field. Internal field. So yesterday I give little introduction about this internal field. So definition also you read. Okay, because those are the simple definitions. So those are useful for everywhere. Okay, now coming to the in future also, that means in future studies, the higher studies also, it will be useful. Okay, now coming to the, we'll discuss about the local field or internal field or Lagrange field. Lagrange field means, so we are taking here one material, so one dielectric material. In that dielectric material, let us consider a point A at the middle of the dielectric material. Let us consider a, so point A. Otherwise, any atom inside the material, so dielectric material. So in that atom, so what is the electric field acting on that atom or point? So what is the electric field acting on that atom or point? That electric field we will call it as internal field. Internal field, or so local field or Lagrange field. Okay, so if they ask whatever, so find out the Lagrange field in a dielectric material. So you can write this one. Otherwise, so find out the electric field inside the dielectric material. So you can calculate. So you can so write this question. Okay. Now we'll discuss here. So let us consider a point A inside the dielectric material. So this is the dielectric material we are taking here. The dielectric material kept inside the two capacitor plates. These are the parallel plate capacitor. So this dielectric material is kept inside the parallel plate capacitor. Okay. So after applying the electric field, electric field, what happened here? So we are applied positive terminal of the battery this side, and negative terminal of the battery is this side. So due to the positive terminal, applying of the positive terminal, what happened? So negative field is induced. So negative field is induced on the surface of the material. Similarly, positive field is induced on the surface of the, so this side. Okay, dielectric material. Okay, now, so we are considering inside. So inside at a point A. So what is the electric field we have to find out? For that, so due to capacitor, there is some electric field will be there. That electric field is, let us take E1 electric field. So that electric field form, so E1, and so due to the induced charge particles, so if you place the dielectric material inside the capacitor, what happened? Charge is induced on the surface of the dielectric material. So due to that induced surface charge, there is some electric field will be there. That electric field is, let us take E2. Okay, now E3. So E3 is, let us assume a one spherical cavity. Spherical cavity means like a football, like that shape is like a football. Okay, in that football there are so many, assume that there are so many atoms are there. So that football is like a spherical shape. Shape means that is the symmetry. Symmetry means if you take, so we can divide that into so number of parts. Now this part, like this part, and so like this part horizontal also, so like this part. So if you will take any part, any half, so this of number of, so number of atoms this side, okay, is equal to the number of atoms this side, because this shape is spherical shape. Okay, similarly if you divide this into two parts like this, means number of atoms in above side is equal to the number of atoms in below side, number of atoms in left side equal to the number of atoms in right side. So each atom will act as a, already I said that. So when you place the atom inside the electric field, what happen? So nucleus will come this side, and electrons will comes to the this side. That means resultant what is that? Resultant charge is accumulated this side. So resultant positive charge is accumulated this side, resultant negative charge is accumulated this side, resultant positive charge is accumulated this side. Okay, so this is the resultant negative charge. So like that, if you will take any atom, so any atom will act as a one dipole. Any atom will act as a one dipole. Okay, that's why if you will take spherical shape, what happen? Number of atoms in both sides. This side is equal, so this side also equal. So that's why what happened? That is the resultant charge inside that spherical shape is zero. Resultant electric field inside the spherical shape is zero. Okay, now so due to these atoms there is no electric field. So there is no electric field, because so all atoms having so electric field. All atoms produces like act as a like dipole, so each atom will produce the electric field. So if you will take, so number of atoms this side is equal to the number of atoms this side. So this side will be, so negative charge is like this direction, so positive charge is inside. So similarly this side positive charge is accumulated this side. So that's why resultant electric field due at this point, due to inside these atoms in the spherical shape is zero. That means E3 is equal to 0. Now coming to the E4. E4 means on the surface of the sphere. So on the surface of the sphere, so due to this positive charge, so what happened? So on the surface of the sphere some charge is accumulated. Similarly, so due to this negative field, so some charge is accumulated on the surface of the sphere, on the surface of the spherical cavity. Okay, spherical cavity. Okay, so we have to, due to this charge, so what is the electric field acting on this point? That is E4. Okay, so we have to calculate what is the E1, E2, E3, E4. So E1, what is the E1 means? Electric field due to the charged capacitor. So this is the capacitor now. So electric field due to the charged capacity is E1, and E2. E2 is the electric field due to the induced charge. So here E1 is the electric field due to the charged capacitor. So E2 is the electric field due to the this induced charge. Induced charge. Next E3, electric field due to the dipoles present in the spherical region. Okay, we are taking here spherical region. So just we are assuming that spherical region, we are just assuming inside that spherical region so many number of atoms will be there. Due to those atoms there is some electric field will be there. That electric field will be E3. Now so E4 is the electric field due to the surface charge on the spherical region. Okay, in that spherical region, so on the surface of the spherical region, there are so many atoms will be there. So due to those atoms, so there is a charge will be there. That charge is so that's E4. So electric field will be produced due to that charge. That is E4. Electric field is E4. Okay. Now calculate the E1. Electric field due to the capacitor. So electric field due to the capacitor. So that yeah, so there is a formula will be there, that is d by epsilon naught. We are placing inside the some dielectric material, that's why. So electric field due to the capacitor E1 is equal to d by epsilon naught. Here d is the displacement. D is the displacement. Displacement is equal to, we can write in terms of electric field. So epsilon naught E plus P. Okay, epsilon naught E plus P. So therefore E1 is equal to, so E plus P by epsilon naught. E plus P by epsilon naught. Okay, this is the electric field due to the capacitor. Okay, now coming to the here. So electric field due to induced charges. So here polarization is occur. So due to the, that means these are the induced charges. Induced charges, due to these induced charges some electric field will be occur. So that electric field E2 is equal to, so P by epsilon naught. That means why we are writing P by epsilon naught means so if you will take parallel plate capacitor, so what is the electric field due to the parallel plate capacitor? E is equal to Q by epsilon naught. Q by epsilon naught. Already what is the Q here? So Q is numerically equal to the, so this polarization. Numerically equal to the polarization. That's why we are writing here. So due to polarization, what happened here? Some charges are accumulated this side and this side. So that's why. So here charge is numerically equal to the this P value, so polarization value. That's why. So E is equal to, actually Q by epsilon naught is the formula. Instead of Q I am writing P, because this is due to the induced charge here happen. So that's why. So P by epsilon naught. What is the direction? What is the direction means here? See here. So electric field direction. Electric field direction is here. So positive to negative. Positive to negative. So previous case we are taking positive. So but here, so this is opposite direction. Electric field direction is opposite direction of the, so E1. That's why we are taking here minus sign, minus symbol. Okay. So E2 is equal to minus P by epsilon naught. Minus P by epsilon naught. Now electric field E3. So electric field, so E3. What is the E3? E3 means due to the, so inside the spherical charge there are so many number of atoms. So those due to those atoms what happened? So that atom having symmetrical distribution of molecules, or are atoms. Okay. So each molecule or atom will act as a one dipole. Okay, one dipole. That's why. So this is symmetrical distribution. Symmetrical distribution means there is a resultant charge, resultant electric field. Resultant electric field inside the spherical cavity is 0. E3 equal to 0. Now E4. E4 is means electric field due to the surface charge particles. Okay, so here if we are considering the spherical sphere. So in that spherical sphere, so due to the surface charge particles, so that means one side negative charge is accumulated, another side is, so positive charge is accumulated. Due to this negative charge, so what is the electric field? Due to this positive charge, what is the electric field? We have to calculate that. So main, this is the important one. Remaining all are we can write directly. So this we have to calculate here. Okay. For calculating the electric field E4. So for that, so generally we know that formula, force. So force acting on a charged particle, 1 by 4 pi epsilon naught into q. So q1 q2 by r square. Okay. So from that, so what is the relation between the electric field and force? So F is equal, E is equal to F by Q. E is equal to F by Q. From that, we can calculate the electric field. Electric field E is equal to 1 by 4 pi epsilon naught into Q by R square. Q by R square. What we are doing here? So what we are doing means, yeah. So due to this charge, so what is the at the point A? Here at the point A also some charge will be there. That's why force acting on this point equal to F is equal to Q1 Q2 by R square we wrote. So but E is equal to F by Q1. So Q1 gets cancelled. So remaining E is equal to 1 by 4 pi epsilon naught into, simply I am considering it is Q. So Q by R square. Q by R square. For that, so we are assuming any surface area A. For that assuming, we will assume the small surface area. So at a time we are not, it is not possible to calculate the all charge particles. That's why, so we will consider the small area. So dA, small area dA. Due to that small area, so what is the electric field we have to calculate? So how to calculate the, so this charge also here, so there is a that polarization is numerically equal to the P is equal to Q by A, Q is equal to P into A. This is the relation between the, so P and Q. Okay, now so area of the ring, area of the, here A is the area of the ring, A is the area of the ring, equals circumference into thickness. Okay, I will explain you. So for getting the electric field, first of all we have to calculate the area of the ring and find out the what is the charge. After that we will get the electric field. Okay. Yeah, first of all, let us assume a small area dA. Let us assume a small area. So this area, okay, dA. Okay, so this area means that spherical shape. So that ball, it will be like a football. I said that. So now we are considering small area means that area we can consider like this direction, like a ring. Okay, so small area, so we can consider, so that small area along the two dimension, we have to consider. Okay, so that means, so that area will be like this side like this, and another side also it will be like this. Okay, total that is the area. Understood? So that is the area we have to consider like this due to that small area dA. So that small, how to consider that small area means we are considering the small area dA. That area will be like a shape of the ring. Okay, so let us assume the football. In that football, we are considering the, so small area with equal radius. So that's why, so this shape will be like this. Okay, now what is the thickness? Of the this area? So the thickness is equal to, so let us take, so that area from the center, so from this point A, so that area having, so radius r, this area makes an angle d theta. So this, so that means area of the angle I am only calculating here. So this area, so area, one point of the area is here, another point of the area, that means it's a radius having some thickness. So that so total thickness of the area making some an angle. So at a point A, that angle is d theta, and so this area, so the position of the area, making an angle theta, that width of the area making an angle d theta. Okay, so and this is the, here thickness, here. So the thickness is r into d theta, so how to calculate r into d theta? I mean, this is the d theta, this is the radius r. So sector, so in sector, what is the sector formula? Sector is equal to r into d theta, radius into making angle. So that's why, so by using sector formula we can calculate the this thickness r into d theta. This thickness will be r into uh, d theta. And so this ring, this like it is like a ring like this now. So what is the center of the ring? Let us take S is the center of the ring. It is S is the center of the ring here. Okay. Now coming to the what is the S also we have to calculate. What is the S of the we have to calculate, because we have to calculate the area of the ring. Area of the ring. So area of the ring means so circumference into thickness. It gives the area of the ring. What is the formula for circumference? So 2 pi r. So r is the so radius of the ring, and so thick into thickness. It gives the so total area. Okay, A is equal to circumference into thickness. Area is equal. Suppose what is the formula for area of the ring? Circumference into thickness of the ring. Thickness of the ring. So that gives the total area of the ring. Okay. Now how to what is the circumference means here? So 2 pi r. What is the radius of the ring here? So radius of the ring is this one. So QS. QS is the radius of the ring. So how to calculate the QS? So we know that A into AQ is the R. AQ is the R. So this is the right angle triangle. Right angle triangle. So this angle is R. So sorry, this side is R. Okay, and here angle is theta. So by using sine theta is equal to opposite side by so this adjacent. Okay, so that's why. So by using the sine theta, we can calculate now. We can calculate. So therefore, so this side QS is equal to so sine theta is equal to how we can write. So how we can write here? So QS by QA. QS by QA. So QS is equal to QA into sine theta. What is the QA value? R sine theta. Okay. Therefore, so by using so this is the right angle triangle, we can calculate the radius of this ring. So this is the radius of this ring, and this is the thickness of the ring. Thickness of the ring. How to calculate thickness here? So this d theta into so r, by using sector formula we can calculate the so r d theta. So thickness of the ring here. Okay. Now so here there are a small charge dq will be there. There is a small charge dq. Okay, so that due to that small charge there is a some electric field. Electric field occur on a point A. What is the electric field? That is let us take DE4. So there is a we are taking small part. There is we are taking small part. Due to the small part, so there is a electric field will be developed. Let us take that is equal to DE4. DE4. Okay, due to the so small charge dq. Small charge dq. So there is a some electric field. This is there is a in that area A. So there is a small charge will be there. That is the dq. So due to that dq charge, there is a some electric field will be produced on a point A. That electric field is DE4. Okay. Now we will discuss that electric field here. Okay. First of all, we will calculate the area. First of all, we will calculate the area. So area of the ring. Okay. So already we know that from the diagram we can calculate the radius of the ring. Radius of the ring equal to r into sine theta. R into sine theta. And so width of the ring equal to r into d theta. Width of the ring equal to r into d theta, and radius of the ring equal to r into sine theta. I said that how to calculate radius of the ring. So by using Pythagoras theorem, here right angle triangle will be there. So by using that right angle triangle, we can calculate the radius of the ring here. Okay. Now area of the ring. Area of the ring formula: circumference into thickness. Circumference into thickness of the ring. So what is the formula for circumference? 2 pi r. So r means radius here. 2 pi into radius. Okay. So what is the radius of the ring? So 2 pi into what is the radius? R sine theta. Radius of the ring equal to r sine theta. Okay. So here we are taking small area dA. So that dA is equal to circumference into thickness. Circumference into means 2 pi into radius. So what is the radius here? R sine theta. And so thickness or width. So width equal to r into d theta. We can substitute those values. So we can get the area. We can get the area. dA is equal to 2 pi r square into sine theta d theta. So this is the area. Now find out the so charge. Find out the charge. What is the charge? So there is a small charge. Let's consider a small charge dq. Due to the small charge, what happened? So there is a some polarization will be occur. That polarization. So polarization P is equal to Q by A. So from this, there is some angle of polarization also there. So that polarization, what is the angle of polarization? So here polarization occurs. So along like so that means so horizontally so it's some there is some value will be there and vertical value also there. So that means what is the direction of polarization? So polarization direction will be like this. So that polarization is divided into two components. One is the vertical component, another one is the horizontal component. Horizontal component. So if you will take here, so this is the one point. Similarly, we can take this point also. This point also. What is the direction of polarization? Direction of polarization is like this. So this polarization also we can divide it into two components. One is the horizontal component, another one is the vertical components. So vertical components. So vertical components are cancelled with each other because so vertical component direction is along this direction here. So similarly, so if you will take this point, so like this direction, so that's why vertical components are cancelled out with each other. Vertical components of polarization are cancelled out with each other. Vertical component means p cos p sin theta, horizontal component means p sin theta. Okay, that's why here vertical components are cancelled out with each other. So only horizontal component will be present. Horizontal component of the what is that polarization? P cos theta is equal dq by dA. Dq by dA. So by using this formula, we are writing here. Okay, dq by dA. So dq is equal to p cos theta into dA. Okay, now so p cos theta. So p cos theta into what is the dA value? dA value already we calculate. So area of the small region. So 2 pi r square into sin theta. Okay, we can substitute the dA value. Already we calculated here area value. dA is equal to 2 pi r square into sin theta d theta. So that value we are substituting here. Okay, now so resultant charge dq is equal to 2 pi into p into so here r square I am writing here. So sin theta into so here cos square, yeah, so sin theta into cos theta. So 2 pi p r square sin theta cos theta d theta. This is the dq. So dq is the charge, small charge. So due to the small surface area dA, so there is a charge dq will be present. That dq is equal to so 2 pi p r square into sin theta cos theta d theta. That is the dq value. Now we have to calculate the electric field. Electric field, so that due to the small charge dq, okay, so there is a some electric field will be produces. Electric field will be produces on a point A. So at a point A, so there is a electric field will be produces. That electric field is de4. That electric field is de4. What is the formula? 1 by 4 pi epsilon naught into, so what is the charge here? dq by what is the distance between the charge and that point r? So r square 1 by 4 pi epsilon naught into dq by r square. Substitute the dq value here. Substitute the dq value. Okay, if you substituting the dq value means dq value equal 2 pi p r square sin theta cos theta into d theta. Okay, so some terms will be cancelled. So resultant is equal to p by 2 epsilon naught into sin theta cos theta d theta. Okay, now so what is the electric field acting on point A? So that is the de4. de4. So due to the small charge dq, so electric field acting on that so point is the de4. That's why here that de4 also divided into two components. One is the vertical component, another one is the horizontal component. Vertical component is de4 sin theta, horizontal component is de4 cos theta. de4 cos theta. Okay, yeah, so now, so vertical components are cancelled out with each other. Similarly, what I said before, so same like that only. So vertical components are cancelled out with each other. So resultant electric field is de4 cos theta only due to the horizontal components. Resultant electric field is due to the only horizontal component, that is de4 cos theta. de4 cos theta. Now de4 cos theta is equal to p by 2 epsilon naught into, so what is the resultant value here? So p by 2 epsilon naught into sin theta cos theta. Yeah. P by 2 epsilon naught into sin theta. So cos square theta into d theta, because here p by 2 epsilon naught into sin theta cos theta d theta, and again one more cos theta will be there. That's why I wrote here cos square theta. See here above and below. So here, so de4 equal just p by 2 epsilon naught into sin theta cos theta d theta. So both side multiplying with cos theta. De4 cos theta equal to p by 2 epsilon naught into sin theta cos square theta into d theta. So this is the de4. Okay, now so this charge is only due to the, so this electric field is only due to the, so this small charge dq. This electric field is only due to the this small charge dq. So if you want total charge, so total charge, so total electric field. So total electric field means what we have to do here. So we have to take integration. So integration means so 0 to pi. So total we have to take, so all directions we have to take now. So 0 to pi. Okay, so 0 to pi. So in all directions, so electric field of in all direction equal to 0 to pi. 0 to pi into de4 cos theta d theta. Okay, now so substitute the de4 cos theta value. So if you substitute means, so p by 2 epsilon naught into sin theta cos square theta d theta. So here p by 2 epsilon naught is constant. P by 2 epsilon naught is constant. We can write outside. We can write outside. So now coming to the only angle is changes. So at different positions angle will be different. That angle varies with 0 to pi. Okay, so 0 to pi into sin theta cos square theta d theta. Okay, so for simplifying this equation, let us take cos theta equal to x. Cos theta equal to x. Okay, now so cos theta equal to x. So limits also we have to change. Let us take here cos theta equal to x. So that's why we have to change the limits also. So for that what we have to do, so theta lower limit theta equals 0 na. So theta equals 0 means what happened, x. So cos 0 value is 1. So now theta is equal to pi. So theta equal to pi means, so what is the upper limit? So upper limit, what is the x value? So cos pi value. Cos pi value means, so cos pi is equal to -1. X is equal to -1. Cos pi -1 na. So now differentiate d theta. So d theta we have to convert in terms of x. So that's why, so dx is equal to differentiate both side. So dx is equal to, so differentiation of cos theta minus sin theta into d theta. So minus sin theta into d theta equal to dx. So substitute here. If you substitute means what you will get, limits are lower limit will be 1, sorry, lower limit will be 1. So upper limit will be -1. So here 1 -1, lower limit will be 1, here upper limit will be -1. So instead of cos theta we are substituting x, instead of minus sin theta d theta, so sin theta d theta we are substituting minus dx. Okay, now so if, limits, so here limits are, we are interchanging the limit. So 1 minute. So 1 to -1, x square into minus dx. We can write minus p by 2 epsilon naught. Okay, so otherwise we can interchange the limits also. So if you interchange the limits means here minus will be cancelled. Interchange the limits means, so -1 to 1. So what happened? So this minus will be cancelled. Otherwise, if you don't change the interchange means, so minus will be outside. We can write the minus will be outside. So p by 2 epsilon naught into, so 1 to -1 x square dx. So integration of x square. So x cube by 3. Integration of x square value is x cube by 3. So lower limit will be 1, upper limit will be -1. Substitute the limits. Substitute the limits means we can get, so -1 cube minus 1 cube. We can get -1. So -2. So -2. So here minus. So both will become plus. So 2p by 6 epsilon naught. So that means p by 3 epsilon naught. P by 3 epsilon naught. This is the E4. This is the electric field due to the surface of the spherical cavity. Surface of the spherical cavity, that equal p by 3 epsilon naught. Now coming to the, so total electric field on a point A. Total electric field acting on a point A. That total electric field is, let us take EI. That because this is internal field. That's why we are taking EI. EI is equal to E1 plus E2 plus E3 plus E4. Okay, substitute the all values. Already we know that E1 value and E2 value and E3 value. So and E4 value we are calculated here. Okay, substitute those all values. First, what is the E1 value? E1 value equal to E plus P by epsilon naught. E1 value equal to E plus P by epsilon naught. Now E2 value. E2 value equal to minus P by epsilon naught. So minus P by epsilon naught. E3 value. E3 is 0 and E4 P by 3 epsilon naught. P by 3 epsilon naught. So this minus P by epsilon naught, P by epsilon naught get cancelled. So internal field EA is equal to E plus, so P by 3 epsilon naught. So this is the internal field. Internal field. Okay. So this is the internal field or Lorentz field or local field. Whatever the formula will be there. So we have to calculate very easily. Okay. First of all, so I will explain you once again. So here E1 is the Q2 capacitor plates. There is the electric field E1. Okay, that value is equal to D by epsilon naught. So that D we can write into epsilon naught E plus P. Okay, if you simplify it, E plus P by epsilon naught. That is the E1 value. E2. E2 is equal to, so minus P by epsilon naught. So E2 is equal to minus P by epsilon naught. So that E2 is due to the induced charge on the surface of the dielectric material. Now, so E3, let us assume the spherical cavity here. Inside the cavity, the spherical shape means that is the symmetric shape. So because that symmetric shape means, so number of atoms. So number of atoms in one side is equal to the another side, upside and lower side, like that. So number of atoms in one side is equal to the number of atoms in another side. That's why, so inside number of atoms are equal. That's why resultant electric field due to, so these atoms and the point A is 0. That's why E3 equals 0. E4 is the electric field due to the this surface charge. Electric field due to the surface charge. For calculating the E4 value, let us assume a small area dA. Let us assume a small area dA. Okay, so that area is like a ring. That area like a ring. Okay. Let us assume for calculating the DE4, so E4 value, we are assuming a small area, so DQ, so that area is dA, here charge is DQ. Okay, so due to this DQ, so some electric field will be generated. That electric field is DE4. Okay, that electric field having two directions. One is the vertical direction and another one is horizontal direction. Vertical directions are cancelled out with each other. Okay, so now for calculating the dq value, what happened? So we require area. Okay, so consider a small, so here for that, for calculating the area, what is the formula for area? Circumference into thickness. What is the thickness here? So thickness or width of the ring. So r into d theta, and so radius of the ring is r sin theta. So why radius is required means here circumference of ring is required. That's why 2 pi into radius. Radius is r sin theta. So if you substitute that value means we can get the dA. So we can get the dA value. From that we can calculate the dq value. Dq is equal to, already we know that. So so p cos theta equal to dq by dA. So from this dq is equal to p cos theta into dA. Okay. So from this, so p cos theta into dA value we can substitute here. We can get the here dq value. So that is the dq value. Now coming to the, because of that dq charge, what is the electric field? That electric field is DE4. So the DE4 value we can calculate here. So that DE4 equal to P by 2 epsilon naught into sin theta cos theta d theta. So so we not require total DE4. So the DE4 divided in two components. One is the vertical component and another one is the horizontal component. So vertical components are cancelled out with each other. That's why we need only horizontal component DE4 cos theta. So equal to P by 2 epsilon naught into sin theta cos square theta d theta. Now, so we have to calculate the total value. Total value E4 means we have to integrate with 0 to 2 pi. We have to integrate with 0 to 2 pi. So like that integration, we are calculating the E4 value. So total electric field. equal to E1 plus E2 plus E3 plus E4. Okay, so this total electric field we will call it as internal field. Internal field. So this is about the internal field. If you have any doubts, means you can ask. This is the most important question. So I will take the attendance. Only just 60 members are there. Huh? Okay, yeah. So if you have any doubts, means you can ask. Otherwise, you can leave from the session.
Sir,
Yes.
sir, can you send the fourth unit PPT